In this session, I want us to focus on geometric sum or the geometric series. Okay, so we know that when we talk of the sum, we denote it by Sn. Okay, so in terms of geometry, we denote or the general formula for this, it's Sn is equals to a into 1 minus r exponent n over 1 minus r. Okay, or you can say this is equals to a into rn minus 1 rn minus 1. So if you interchange whatever is in the bracket, if you start with rn, even on, I made a mistake here. Okay, now everything's good. If you interchange r, if you start with r in the bottom, also you must start with r. Okay, so this is the general formula for this geometric sum. Remember, in geometric, that is the kind of sequence or series that has a common ratio. Hence, we see r in our formula. Okay, consider this series 3 plus 6 plus 12 plus 24 plus 48. Okay, so this is our series. So if a question comes and say calculate the sum of the first 20 terms of this series, okay, so from the formula wants the value of a, which is the first term, then the r value. We know that to find our r value, we say t2 divided by t1. Okay, so it means we're going to have 6 divided by 3, and then we have 2 as our r value. Okay, so if we have our r value, we also have our a value here, which is the first term. Then we can calculate the sum of the first 20 terms. So the sum of the first 20 terms will be equals to the first term, it's 3 into 1 minus, and then our r value is 2, then the sum of terms that we are calculating for it's 20, then all divided by 1 minus 2. Then here we should get an answer of, then when we press our calculator, we should get an answer of 3,145,000, okay, 720, is it 26, 725, something like this. So this is the sum of the first 20 terms of this pattern. Okay, so let's look at an example. So our example is here. Okay, given the geometric series, we're given 256 plus p plus 64 minus 32 plus, and then our series goes to a certain number. It goes to infinity there. Okay, so they want you to determine the value of p. Okay, notice that this is term number 1, this is term number 2, this is term number 3, this is term number 4. Okay, so in this case, to determine the value of p, we are going to use the formula for confirmation. T2 divided by T1 is equals to T3 divided by T2. Okay, so our T2 is P, then we divide it by 256, which is equals to T3, it's 64, okay, divided by P. Then when we multiply, we're going to have P squared is equals to 64 by this 256. It gives us 16,384. Okay, so it means we must find the value of p, or the possible value of p. It means we must take square root both sides. So it means p is equals to plus or minus, okay, 128, because we took the square root Okay, so it's plus or minus. So in order to choose whether it's plus or minus, okay, remember this formula for confirmation actually is just to show us the common ratio, to confirm the common ratio. Okay, so we can use term number 4 and term number 3. Okay, so r is equals to t2 divided, term number 4 divided by term number 3. Our term number 4 is negative 32, then term number 3 is 64. Okay, so the ratio here, it gives us negative 1 over 2. Okay, so when we say r is equals to t2 divided by t1, then our t2, we know that p is equals to 128 plus or minus 128, then divided by 256. Then we're going to have 1 over 2 if it's positive 128. But if it's negative 128, it means we're going to have negative 1 over 2. And then we want our common ratios to be the same. So it means the value of p, therefore, the value of p is equals to negative 128. So that our common ratios are the same. We cannot be having a positive common ratio between two conservative terms and then on other conservative terms it's negative. So it should be constant, just like that. Okay, so this is the value of p. Then now they want you to calculate the sum of the first 8 terms of the series. Okay, so to calculate the sum, we know that the formula says Sn is equals to a into Rn minus 1, okay, over R minus 1. All right, so a is the first term, R we know it, and then where we should calculate the sum of the first 8 terms. So we're looking for S8, and then the value of a, it's 256, it's 256, okay, into the value of r, it's negative 1 over 2. All right, and then n in this case is 8, n it's 8, and then minus 1, and then divided by negative 1 over 2 minus 1. Okay, then when you press your calculator, you should get the value of 170. So the sum of these terms, it's 170. Okay, the sum of the first 8 terms, it's 170. So because you can see they are alternating, this one is positive, this one is negative, this one is positive, this one is negative. So when you add the first 8 terms, it gives you the value of 170. Okay, I hope we are still okay, so that we can check on this example here. So it says the 8th term of a geometric sequence is what? Is 10, and the 13th term is 320. Determine term number 15. Okay, simple as ABC. So in this case, we are dealing with a geometric sequence and a term from a geometric sequence. So remember, geometric sequence is given by ARN minus 1. Okay, so they say term number 8 is equals to 10. Also, term number 13 is equals to 320. So this is a simultaneous question, guys. So we can solve this in this way. For term number 8, it means we're going to substitute 8 here, AR, then 8 minus 1, and then term number, the value of this term, we know that this is 10 AR7 there as the exponent. Okay, so this is the equation 1. Okay, so term number 13, we know that we're going to substitute 13 here, and then AR 13 minus 1, then the value of this term 13 is 320, which is equals to AR exponent 12. Okay, So this is our equation 2. Then we can make A the subject of the formula and then solve for the rest of these things. Okay, so from equation 1, which our equation 1 says 10 exponent 7, we can divide both sides by r to the power 7. We can divide both sides by r to the power 7. So it means A is equals to 10 divided by r to the power 7. Let me write that one well. R to the power 7. So it means we can substitute, from there we can substitute the value of A into equation 2. Okay, so equation 2 says 320 is equals to A r to the power 12. So when we see A, we're going to put 10 divided by r to the power 7. So it means this is 320 is equals to the value of A, it's 10 divided by r to the power 7 multiplied by r to the power 12. Okay, then from here we know that this is over 1, so it's direct multiplication. So meaning that we're having 320, which is equals to 10 r12 there divided by r7. Then when dividing powers of the same base, we subtract the exponents. So now it means we're having 10 r12 minus 7. Then we equate it to 320. And then we're left with 10 r5 there. Then we can divide both sides by what? By 10. And then this one will divide this one. And then this will divide this. 32 divided by 1, it's 32. So it means we're having 32 is equals to r to the power. Then we can take the fifth root of 32 and then the fifth root of r5, and then our r value becomes 2. Okay, so we have our common ratio now. Okay, so but the question wants us to determine the 15th term. So we know from the formula, if we want T15, we must have the A value and the R value. So far we have the R value. So to find the A value, we can take this and substitute R inside. Okay, so A is equals to 10 over R to the power 7. So it means we can have 10 divided by 2 to the power 7, and then which gives us 5 over 64. So this is the A value. Okay, so now we can determine the 15th term. T15 is equals to A value, it's 5 over 64. Then our R value is 2, and then raised to exponent n, it's 15 minus 1. Then when you punch your calculator, you get that this gives you 1280. Then you are done and dusted. So this is how we approach this question. Okay, so I hope it makes sense. I hope you are not lost. If you feel like you are lost, you can try to rewatch it again. But if you feel like you don't understand and you want clarity on some other questions, I'll put my email address on the description, and then you can also comment on the video, okay, so that we can communicate. So see you in the next one. Bye bye.